Okay, let's get started. Louis, do you want to present the update you just you sent in the group chat? And yeah.
Yeah, sure, absolutely. I could do that.
Yeah, you can share your screen if you want.
Yeah, sure. Let me do that. So let's see if this works. Can you guys see this?
Yeah.
Excellent. So pretty much what we have here is I should describe what the project is and how this can likely help with the production vLLM stack.
Mm-hmm.
Um, the KDevOps project is basically an automation framework for testing very complex subsystems and also development automation. So it addresses both. Um, and over time, essentially what we've done is given that we've implemented support for automating very complex subsystem testing and development, we figured this could likely scale to other subsystems in the automation that we have could likely help other complex subsystems. And I think that the production vLLM stack is one example of these.
Mm-hmm.
Um, Essentially what the project is a combination of Ansible. Um, it uses kconfig, which is basically the modeling variability language, and then it supports both local virtualization. It also supports bare metal hosts, meaning that they're already pre-provisioned. And it also supports cloud. By cloud, I mean that essentially it supports the ability to uh, essentially let you bring up as many instances as you want for the defined target workflow. One of the beauties about this, though, is that essentially once you define the workflow, you have support for these different workloads that are supported under KDevOps under these different bring up environments. So although my initial patch for KDevOps was to essentially add support for the production stack, and I tested it on virtualization, it now has support for cloud, and that only took a day or two. So essentially, what we have is we start off with a typically a, a configuration, and this is essentially how you would typically modify, for instance, the Linux kernel when you're compiling the Linux kernel. We basically borrow the same exact type of framework into this, and we allow you to specially modify how you're going to bring things up. So by default, it assumes that you're going to be using virtualization. Uh, and this is the option here for virtualization. You can skip that and just use Terraform, for instance. And then once you select Terraform, you can configure your cloud provider that you want to use. So we have support for all these different cloud providers, and it can grow easily. Basically, so long as they have a Terraform provider, we essentially can add support for that cloud provider. So that means that the production stack can now run under these different cloud providers with automation in mind. Now, given that you don't likely always want to run this configuration manually, we support also defining predefined configurations, and I'll review that in a bit. So let me show you how we configure. See, then we want to configure the vLLM stack. So in this case, we just want to go down to the vLLM, and then here is how we configure the production stack. So any variability that you can think of for the production stack can be added here, and this just becomes part of the symbol definition for what it is. And we basically provide a description. You press question mark, it'll describe what this is, and it's part of the documentation. One of the beauties about this too is that this provides a mapping between the symbols, and given that it has documentation, this allows us to scale as well, because we're essentially also providing documentation for LLMs that also allow us to not have to actually do any modification for this project using any manual development. We basically at this point just do development with AI agents. So let me, now that I have done this, let me just exit and let me just start from scratch. And I'm going to show you guys how to run this if you already have a predefined vLLM configuration. In this case, we have one for Lambda Labs. So as an example, it was added here. So all I have to do is use this one. So this is basically just using all these options that you typically would configure are pre-saved into these configuration files, and then basically just run make. And this is now propagating those defined symbols into YAML-friendly files. And as you can see, it's running Ansible tasks. This is how it's basically working. This is just setting up the environment for us to eventually run the bring up. The bring up is essentially how we basically bring up the actual cloud instance. We provide different verbose options. If you want to be verbose with Ansible, we support AV equals 2, for instance. And this may fail, and if it fails, this is basically what I expected. So as you can see, we're actually out of capacity right now in Lambda Labs with this type of instance. So unfortunately, I can't proceed with the demo at this point just because of the capacity issue, but essentially I had tested this before and I know it does work as well. But in the end, let's say if this does come up, then you should be able to just run vLLM. And then that should actually get the full production stack on the cloud instance. I think what I can do is I can actually try to have a pre-recorded session with the actual cloud instance once they become available. And then this might be useful for others in terms of documentation. But the same exact commands essentially can be run through any cloud provider. Does that make sense? And also, do folks have questions?
Yeah, this is super helpful. And so I was just wondering, how can we modify the configurations we want to use for the deployments?
Yeah, so basically, there's different ways, right? So if you have so by default we have the vLLM dev configs. These are for the production stack, for instance. So and then you can use one of the features that we support is declared hosts. So if you have a system that's already up and running and you want to skip the whole bring up process because they're already up, then you can, for instance, use this one. So I would do, for instance, make dev config and then this one, and then declare host, and then the name of the host that you have SSH access to. So in this case, it could be like, let's say Prune, which is one of the systems that I have. Then run make, and then run make vLLM. That'll actually try to get this up and running for that system. To modify the configuration, all you got to do is just modify the vLLM production stack for, let's say, this one would be the declared host GPU. And these are basically um, just symbol definitions for all these different configuration options. And these map into kconfig, so I can show you where that is defined. So for instance, if you get grep for this, you can see where this is defined. This is in the workflows that, for vLLM. And this is the file that defines the vLLM production stack variability. So these are the symbols. And then this is it's a Boolean, or it could be whatever, a string, and this is the documentation for it. So here you can add support for new features, and you can extend it if you want to see what options are provided. Here's an example of the deployment types that are supported. Here's an example of a multiple choice option for different Kubernetes deployment methods. Um, and yeah, I understand this might be a bit overwhelming at this point, but this is kind of like the bare bones of how this essentially works. And the other thing too is obviously what we want to do is also add the emulation support into the vLLM production stack, so that way we can essentially run even without any Docker images or anything like that. So that way it could stress test the routing. So that'll be next on the agenda as well. So that way we can help with the automation for that as well too. Does that make sense?
Yeah, yeah. And also like I was wondering, does this like is this like for example VLM router enabled map to some fields in the Helm chart? Is a mapping to
Yeah.
a variable?
Yes, it does use the production stack Helm charts.
Okay, and how can we check like where can we see the mapping?
So this would be part of the playbook for
Okay.
vLLM. So this would be the we have a playbook here, and then basically it would be in the main here. These are all the tasks that are run, and you
Mm-hmm.
can look for the Helm chart here. So as you can see, there's like a series of tasks that are run.
Mm-hmm.
What I'm not sure if folks are familiar with Ansible, but basically this is the way that we define a variable, for instance. Here's a VLM local path, for instance. So everything that you were modifying through the make and config is a variable defined here, for instance. And then these get propagated after you run make into the extra bars file. So in this case, this is this file, and this has a whole bunch of variables. In this case, that was not one of them,
Mm-hmm.
but a whole bunch of VLM variables are defined here.
Mm-hmm.
So the
I see.
what you modify through nconfig gets propagated here, and then these get essentially used for the Ansible playbook.
Mm-hmm.
So the Ansible playbook, and if you want to see how the Helm charts here, let's look for the Helm chart. Here's an example, but let's go earlier. So it's the Helm namespace here. So this is the first one, I think. Yeah, so check out the playbook. Let me know if you have any issues, have any questions. I can follow up with them. Here's the see, this is actually including another task of the deploy the production stack, so we can look at that. This is the setup Helm chart. So this is I'm looking at the second task here at the top. And that's it. So everything's broken down into, self-contained uh, tasks in Ansible. But yeah, let me know if there are questions. We can address them through either Slack or we can address this also through a mailing list. It's not just me working on this project as well. So
Okay.
one of the nice things about this is that other companies are interested in this stuff. They've been working on KDEVs for a while too. So there's a community out there that can provide support for this project as well too.
That's nice. That's nice. Yeah, can you submit a like write a tutorial or something similar like in the production stack repo like submit a PR for that.
Yeah, sure.
That will be really helpful for users to try it out. And we can also
Yeah,
send this PR in the vLLM Slack and to let users try it.
I have a
sure.
question. I came here a little bit late, missed out, some parts of it. But like, did you also provision the infrastructure for that? Like you talked about the Lambda lab. Will you also set up Lambda infrastructure, like the machines there also?
So basically, you can run it on any cloud provider. Lambda Labs is just one of the example cloud providers that we support. Um, but basically, this is basically scalable to be run, given that KDEVs already supports different cloud providers. Uh,
Mm,
all cloud providers is essentially supported. Now, I should describe briefly that if you think about how cloud providers grow, they obviously add new instances every now and then. The regions modify and they grow capacity and so forth. So one of the challenges with essentially providing this sort of framework of being able to dynamically configure something through a console is that things may change. So one of the things that we are now working on is essentially supporting um, an option to generate the configuration options for cloud providers dynamically. And this basically goes to the cloud provider and gets all the information. And on the fly, we provide the configuration options that are available. So that's something that it's really neat to this project that we've been embracing, but that should help because it means that you no longer have to be updating, let's say, the new GPU instances or what distro images are available and so forth. That should eventually automatically be populated for you. Does that make sense? Does that any questions regarding that? Or did I answer your question actually?
I'm not quite sure actually. Like, so is yes. So you also provision the infrastructure in the playbook or a Terraform?
Yeah, the entire dependencies of what you need to run the production stack are installed for you automatically as part of this
I
process of
see.
make
I see.
vLLM.
Mm,
So the goal here is to basically allow you to easily deploy the production stack from ground zero, like starting
mm,
from scratch,
mm.
and make it easily reproducible.
I see, but like, so whenever there's a new cloud provider, let's say, Nebius, do we have to like make modification to suit that cloud provider because they might have different API to provision the infrastructure?
So to answer that, the question really is there a Terraform provider yet that's implemented for that cloud provider? Is the answer is yes, then essentially it's easy because all we have to do is add support for it. But I should describe that um, I don't do any manual development for this project anymore. I used to, but given we've constrained the grammar in this project to allow it, given that we're using Ansible and kconfig, we narrow the scope of what an LLM needs to implement. And because of that, their accuracy tends to be a bit much higher than other projects. So essentially, all I would really do is actually just use Codex or any cloud provider, any coding agent, and I would just prompt it to basically, so in my case, I have this. So and then I basically just, what was the name of the cloud provider?
Nebius.
Nebius?
Yeah.
Yeah.
So that's actually what I really would do to add support for this cloud provider. If not, then I would just go ahead and implement it. And how would I do it? I would just use something like Cloud Code.
I see.
So, but we already have a pretty long um, um, we already have a long cloud.md file that instructs the LLM to also understand what the project structure is like, how to add new cloud provider support. And in fact, we also have support for, let me see if I could just get you that. Sorry. Well, let's let this, actually, no, I can do that here. I could show you here. The Lambda Lab support is an example of a that's something that was prompted. I didn't do any development in it. And an example was the prompt that was also used to instruct it to add vLLM production stacks. So Lambda Labs was another one. So let's see, I can look for that here. So we have a collection of the prompts that we use for this project and the respective Git commits. So that way you can also learn how to add support using an LLM as well. So in this case, I just instructed it to add Lambda Lab supported as a new cloud provider, and then it just went ahead and did it. So you can see here it's still working. So yeah, if this works, then basically if someone does have access to this cloud provider, then I can send them a branch and then they can test it.
Oh, okay. Thank you so much. It is super cool.
Okay. Thanks.
Sure.
Thanks, Louis, for presenting this. Any
Yeah, sure. My
questions
pleasure.
from, yeah, any other questions for Louis? Okay. I think that'll be it for this week's community meeting. And if there are no more questions, we can end here and see you guys the week after next week.
Okay.
Okay.
Thank you
Thank
so
you,
much, guys.
everyone.
Thanks, everyone.
Thanks. Yep.